Hey man, this is a note from yourself to your future self, and it has to do with understanding how mutable and immutable objects work in Python. Pretty important stuff. Apparently, when you initially learn Python, you pay not too much attention to these subtle details, but when it comes to actually writing a full fledged program, this type of stuff comes and bites you again. So, mutable objects, when created, their value cannot be changed. Believe it or not, integers are mutable. So if you have a and the value of a is 1, and you have b and it is pointing to a, if you change the value of a to 2, that's a totally new variable. If you check the ID of a and you check the ID of b, they are totally different variables. Integers in Python are mutable. So b should still have a value of 1. Now, this is subtle stuff, probably not that important, doesn't cause an issue in the long run. What we will see in real life is immutable objects like lists. Let's say you have list 1, and that is 1, 2, 3, 4, and you have list 2 that is equal to list 1. A list is an example of a mutable object. So if I do list 1 dot append 5 and print list 2, now list 2 has 5 elements, 1, 2, 3, 4, 5. If I do ID of list 1 and ID of list 2, both are pointing to the same memory location. Now, again, this is subtle, not very important. But important stuff is with understanding how copy works. Now, if I do a copy of a mutable object in Python and assign it to another variable, it creates a duplicate object. Okay. So if I do list 1 is equal to 1, 2, 3, 4, and list 2 is equal to copy dot copy of list 1. Now list 2 is a totally new variable. If I do ID of list 1, I get this. If I do an ID of list 2, I get that. And if I do append list 1 A5 and print out list 2, list 2 correctly shows that it doesn't have the value of 5. So again, this is subtle. This is not important until you are introduced to deepcopy, and you wonder what's the real difference between copy and deepcopy. Because deepcopy apparently does the same thing too. So if I have list 3 and I do copy deepcopy of list 1, it has the same effect of doing the copy initially to the untrained eye. So list 3 has 1, 2, 3, 4, 5. If I do list 3 dot append 6, let's say, and let's show that list 3 and list 1, and you can see that they are two different variables. They point to the two different memory locations. But the difference between copy and deepcopy is how mutable objects inside the object that's been copied are treated. In the case of copy, if you have a mutable object inside the object that's been copied, the reference is preserved. But if you have if you deep copy the object, everything inside that mutable object will be recursively duplicated, and all the references will be separated. Okay, so let's try that with a dictionary that we call original. Let's create a key 1, a key b, a equal 1, b 2, and let's just play with this one, okay, for a second. Now, dictionary is an example of a mutable object. If I have a O2, which is original, equal to original, if I show the ID of original and ID of O2, you can see that both point to the same location. So if I did O2 C is equal to 1, 2, 3, 4, okay, now if I printed out original, it will have the key of C. So a dictionary is an example of a mutable object. When you make the assignment, these two objects are essentially pointing to the same memory location. Now let's play with copy a little bit, because that's where the difference come in. So let's call this a shallow copy and do a copy of original, okay, and this is a shallow copy, okay, and let's do a deep copy. Okay, so now we have two more copies of original. Let's show the ID of original, let's show the ID of shallow, and let's show the ID of deep. Initially, and to the untrained eye, these all look like different variables, and they are. If I added a key to shallow, okay, let's add KD, and that is 1. Okay, original won't have it, and deep will not have it. Okay, but if I modified a mutable object inside the dictionary, in this case key C is a list, which is itself a mutable object, the reference of that list is still shared between the original and shallow. So if I did shallow C dot append 5, okay, so this is going to add a 5 to the list at key C in the shallow dictionary. But if I printed out original, you can see that that mutable object inside it, inside both of these, are sharing that reference. And here's the difference. If I did the same, but if I printed out original, like if you print out original, you can see that that key does not have that 5. The list doesn't have a 5. And if I did the same thing now to the list in the deep version of the dictionary and added, let's say, a 6 and printed out deep. Okay, now deep has 6, but shallow has 5, and original has 5 too. I think this is pretty important stuff. So deep copy, if you want to make sure that you make an exact copy of a mutable object that's dereferenced at any level, use deep copy. If you still want to maintain the references to the mutable objects inside that original dictionary or mutable object or whatever you're copying, normally objects, use copy. And that's it. You've been warned. Stay safe. See you in the next one.